So, quickly about me, my name is Jostein. I come from Bergen and I work at Miles Bergen as a full stack developer. Currently working with the real estate property portal yem.no, where we also have a lot of AI applications. So, large language models. I just wanted to do a quick test. How many of you have tried one of these? Just raise your hand. I was hoping for everyone, that's good. Else we would be not, maybe I would miss the audience. But yeah, this is maybe the most hype ever, or at least as far as I have lived. I was 2 years when the dot-com bubble was, so I don't know really how that went. So they have some things they're really good at, like they have sophisticated language understanding. They know about everything, broad general knowledge, and really good at creating content. You can just say, write me a 100-page essay, and they just go on, and it's content, but yeah, maybe not the best you want, because they have some limitations. They have something called a cutoff date. So you train, because you only have data until the date you are training the model. When then new things get released after this date, you don't get the data into the model. And they cannot interact with systems or external systems because they're just text in, text out. And now I'm talking about the base models, like when you call the GPT API through OpenAI or whatever. If you use the ChatGPT app or the Google Gemini app, they have built a lot of stuff around it. So they will do Google searches and stuff to actually get more content to combat some of these limitations. But let's look at these limitations. So how do we give the LLM access to relevant information and not let it only depend on the whole internet it has trained on? It's very hard to find the correct context. So we have earlier had something called RAG, or it's still relevant. It's called a retrieval augmented generation, which is you have vector encoded text, which then based on your input, you can find relevant context in your database. I don't know if you're familiar with this, but it's helpful for building chatbots. That's one way you can kind of get more content. And how do you enable the LM to perform actions? You can probably build your own system where you'd say, if the output of this model contains the word action, do something. But that's not going to scale, because then you need to do everything yourself. So this is where the model context protocol comes in, which is MCP. And you can think of this as kind of the USB-C port for connecting the AI applications to external systems. And if you think this is just a scribbly line, I thought so too. But this is the letters M, C, and P embedded in this logo, which is kind of cool design. So you have maybe a set of AI applications, like Cloud Code, Cursor, VS Code, or your own application you want to build, which then maybe you want to interact with GitHub issues, create pull requests through the chatbot, or get your Figma designs into your AI editor's chatbot so it can generate correct designs for you, or get your Slack messages, or connect to databases. And the background for this protocol was from Anthropic, the creators of Claude, which the protocol is now open source, but it was something Anthropic used internally for Claude. But now it's open source, but they were the main contributors. So in their blog post, they said that every new data source required its own custom implementation, making it difficult to scale. So they wanted to make something generic. And this is, the MCP is now becoming the main protocol AI applications are built on. So in this presentation, I'm going to walk through the architecture and the main concepts. So when you hear the buzzwords about MCP, you can actually understand a bit more. So we have 3 main participants. We have the MCP host, which is the application that and it can run multiple MCP clients. And a client is something that maintains the connection to a server. You often hear about MCP servers, and they are maybe the most important thing I'm going to be talking about today, because they are the ones that actually provide the context and do the work. So the client just kind of is the bridge between the AI application and the server. And the host would be like Cursor or Claude or VS Code. So the architecture is the host has multiple clients, which has one-to-one connections with each server. So if one server dies, the other one hopefully still works. So let's start with the most important thing, the servers, where the work is actually done. We have three main features related to servers. We have tools, resources, and prompts, which I will go through. So we start with the tools. I abused the Gemini image creator tool inside Google Slides. So I had some fun with generating the images. So the tools is something that enables the AI models to perform actions. And it can have typed inputs and outputs, so you don't just hope that the model can call it the right way. You have, if it wants a string or a number, it won't work without it. So we have type safety. And the important thing is the LLM itself decides when to call the tools. So it only has two functions in the protocol, which is list all the tools and then call a tool. And here is an example of a tool called search flights. And you can see it has a description and the input schema, which tells you, okay, we need the origin, which is the type of string, and the destination and the date. You can have some validation. And then the AI will use the description to kind of know what to put in the different property types, and use the description to know which kind of tool it should use. So here is, for example, how I could use this to help me come here to this conference today. I would hopefully make the AI LLM call this tool call. So moving on to resources, we have it basically is access to information, like a resource, kind of obvious name, but it can expose data from files, API, databases, etc. And how you define a resource is based on a URI, which is just a file path or a server path. So we have two different types of resources. It can be a direct one, which is a fully defined URL. And you also can have dynamic URLs, which here we can have city and category be dynamic. So you don't know. It would be hard if we have to generate activities for every city and put them in our database instead of just, okay, let me search when you request this resource, then we can actually perform the search. And in the protocol, we have four methods for resources. You can list the resources, and you can list the resource templates. The templates were the dynamic ones, where you can have custom parameters. And then you can read a resource, and you can subscribe to changes. Because if you always want to have the newest data, it can be useful to know when it has updated. And here's an example where we have listed the resources, and we only have one, which is on this URI, which is a Rust main file, which has a description and title. So then you can try to read this. So you send this request to try and read the file, and then the MCP server will respond with the contents, which in this case, it was only a main function printing hello world, but it might have been whatever resource you want. And here is kind of the template resource, where you can just how you can get a weather forecast for any city and date. So, prompts, the last concept of the servers. Prompts is basically predefined queries for the LLM, and there's no specification in the protocol of how to expose the prompts to the users. So here is just an example from their documentation of how you could, in the UI, expose a prompt. So instead of the user having to write describe this pull request for me, then you can just have a short snippet saying GitHub PR description and just run that, and the server will actually use a more full prompt that the LLM can understand, like we have here. So you say, this prompt is called code review, and it has a description which the LLM can use. And then we have the code to review is the argument. So to call this, you just send a get prompt, which means get the full text that I will now afterwards use to put into the LLM. And if you put in the hello world function here, then we get this response, which is please review this Python code, and then the argument we put in. So in this case, it was just putting please review this code and then putting the code. So to summarize the servers, we have the tools is functions that the LLMs can call, and the resources is data we can read, and prompts are instruction templates. So MCP clients, the next part. The MCP clients also have 3 different features, same as the servers. So we have sampling, roots, and elicitation, which is a new addition actually. I think it landed in June. And we will now go through each of these. So sampling is, I just wanted to have a quick digression. I asked the AI to make an image of an MCP server, and this was what it thought the MCP server was. So yeah, just wait till you see what the AI thinks itself will look like later. So sampling enables the MCP servers to call LLMs through the client. So if the server wants to have access to the LLM, it can then use sampling. So then here, AI thinks itself is this big brain. That's what the LLM thinks of itself. So we have the server, client, and the user, which is us using the application, and the LLM. So first, the MCP server is like, I need some answers. I need to ask the LLM a question. Then it goes, okay, I want to sample. And then the client goes, are we allowed to do this? And then the user needs to say, yes, you can send this message to the LLM. And this is called human in the loop review, which is, it's useful to have so you don't just spend all your tokens on the useless queries. And then you will send the approved request to the LLM, and you get back the generated response. And then the user can also review the response. And then last, it goes back to the server, and then the server is happy. So this is kind of the quick overview of the data flow. And yeah, there is a big warning in the MCP documentation page. There should always be a human in the loop review. So just if you're making AI applications, please always use human in the loop review. And this is how an example request could be. The server could say like, oh, I want to know the capital of France based from the LLM, and then the assistant can respond with the capital of France is Paris, and you can see I would use Claude 3 Sonnet to do this. So roots is maybe the most boring part. It's basically URL. Here is kind of everything related to roots. You can list the roots and get them back, and you can get notified if they change, but you don't need to really care that much about this. It's only file paths that you just say, this is the parts where you need to focus. This is most often this is where my code is. So then the servers will know where to focus. But this is very important that this is not anything to do with authorization. If you specify the routes, it does not limit the server to only be able to adjust the code on that path. You need to have correct permissions in place anyway. But it's just the guidelines, the routes. And the next part, elicitation, was actually added, as I said, recently, which is the server says, I want to ask the user a question, not the LLM, which was sampling. So here you might have server. It says, okay, start elicitation, and then the client will go maybe present some UI, chat input window, something, and then we get the answer back, and it gets sent to the server, and the server can then continue processing the request, and the server is once again happy. So, also a warning here, you should not try to get sensitive information, and if you are going to use these approaches, I recommend you please just go through their official documentation to see the guidelines for how you should implement this. Because there's, with GDPR, a lot of issues if you don't do this correctly. And here is a simple example where the server would like the GitHub username of the user, and then it has, in the schema, it requires the name type string. So, the message and the name, this is the most important parts here. The other ones are just kind of extra metadata about the request. And then we say we need to have the name. We can also have optional fields in these elicitations. And then I might enter this is not my real GitHub username, but this is my example username. And then the server can continue. So to summarize, the three client methods are sampling, which can then get LLM responses through the client, and then the routes, which I said were boring, but they're useful. And then elicitation is to get client to ask the user to get the responses. So, how to get started with MCP if you want to explore this? So, recently, GitHub launched something called MCP Registry, which is still very fresh, but it's a community-driven collection of MCP servers where you have a lot. I think it's only around 44 right now, but it's still pretty new. But their vision is like, this is going to be like the portal where you browse MCP servers. So time remains, and we will see how far we get with this. But here we have, for example, the GitHub MCP server, where you can read issues or file pull requests through their MCP server. And Context 7 is something, it's the second most popular here. It's 33,000 stars, which has up-to-date documentation about every programming language you want, or they have most of it. So instead of, I don't know if you have tried making prompting to get a React app or using Next or whatever, and then it just made up something, or it uses like 5-year-old functions that's really annoying, and it doesn't work in the new versions. And then if you use, for example, this MCP server, you can say, okay, use Context 7, and then it grabs the up-to-date documentation, and you will get a much better result. And for Figma, for example, you can, as I mentioned earlier, have it connected to the design. If you are a front-end developer, you can say, okay, use the Figma design to make this component for me, which makes it a lot easier. And for Azure, you can also make it I haven't tried Azure one, but I imagine you can get it to spin up resources for you or have connections to your Azure cloud. So you can also build your own server, which is really easy with the use of these SDKs. So this is all the programming languages which are supported officially by the software development kit. So if you don't see your favorite language here, I'm sorry for Haskell developers or whatever you want, but you should be able to know one of these. And I have tried quickly just a Python server, and this is all the code I needed to have a MCP server with tool, resources, and prompts, so we can quickly see how easy it is. This is really all the code you need to have a server. It's 2 lines of code. But then to add like a tool, you say, okay, add MCP tool, and then you make a function. So this is really just the MCP functions and tools and everything is just functions that you say, okay, this is a tool, and then the framework around it knows what to do with the function. So the resource, you define, for example, like this. Here is an example of a dynamic resource, which can take the name as a parameter, and then we see we have access to the name in the function. So you might wonder, what is the difference between a tool and a resource? And the real answer is they're all functions. So I also read some discussions about this online, but it's kind of conflicted. Somebody says, oh, you should always use tools, but I think of more like, if it's something that's read-only, you should use a resource. And if it's performing an action, it makes more sense that this is a tool, because the protocol doesn't enforce anything of what you put in this function. You can drop the database or whatever in a read request, but that's your fault. It's not prohibited by the protocol. So the next part of the code was a prompt, where here you can have generate a greeting prompt with different styles. And again, the prompt is also just a function, but this one should always just return a string that then is used further on to put into the LLM. And when I ran this server on my machine, I didn't know I would get this, but I got this fancy dashboard for like managing the server. And then you can see you have the resources, prompts and tools, sampling, elicitations, routes, everything, and you can click around. And if you go to like, I want to make a prompt, so I want to make a greet user with the name Truls and style friendly, I would get the response as, please write a warm, friendly greeting for someone named Truls, which was the prompt we defined earlier, but now it's finished templating. And then this would be then, you can send this to the LLM and then get a response. So I hope you have learned something about the Model Context Protocol, and yeah, thank you for your time. And